So guys, welcome to the second video on machine language burnout. But this one is just based on solving this problem that we have here, or scenario or question that we have here. So basically it says, write a simple machine language program that stores the contents from memory location 6 to initialize 255 into location 8, which is initialized with a value uh, of of 0. So basically there's another confusion that I think most people have, which is the following. This statement says a program that stores the contents from memory location 6 into location 8. So just for a moment, when you read something, things like initialize, just ignore them for a bit in order to understand what they need you to do. So the main thing is to store the contents from location 6 to location 8. Then location 8, it is initialized with 0. Now this 255, you must understand, it is not initialized in location 6. No, it is just initialized in the program. So as I said on the previous video, when you run a program or whatever it is, your operating system, it will load the values like this one, which is data. It will load data and instruction inside the memory. So like okay, let's just start with this problem. Right now, let me just move this aside. And so basically on my videos, instruction is what I want to include basically. So we have location in binary, right? I don't think that space will be enough. Let me just we'll have a location, and also we will have our data and instruction. Data or instruction in binary, right? Now let's just have a straight line over here, which is dividing the two. Right now, let me just move that a bit downwards. But since we have read to understand what they want, I can just move this away basically. All right, let me just move this away over there. I will take it when I need it. So the first instruction for us to move from, okay, let me make a visual so that you can a visual representation so that you can understand what's happening here. Now you have your CPU here, you have your register, right? This is your memory actually, right? So what happened is that we have memory location 6 and 8. So we want, let me use another color for you to understand. We want what's in here to come here, but it just cannot go from 6 to 8. What should happen is transfer it to the CPU to that location. Now how does this how does this process work? So let's start. So our first iteration 0 0 0. Okay, since I said location, which is just an iteration of what, of program counter, it has 12 bits. Now this is a 12 bits or bytes, whatever it is. Now this is a 16 bits, right? Therefore, yeah, I'm passing that part. Now it also serves as an iteration here. I'm sorry, let me just write it again. So it also serves as an iteration of what, of your program counter. And then this one serves as a value or what, or your instruction. And then let me pass that again. Right now, let's go. Oh, the other thing is that your first values here, your first 4 bits here, they represent your operation code. Then these next 3 bits here, they represent what? Your operand. Your operand can be a value, or it can be a representation of what? Of your memory address. That those 3 bits are basically what? Your operand. And then the first bit, the 4 bits are what? Are your operation code, which is given actually. Therefore, you can say your 16 bits data or instruction, it is divided between opcode and also your operand. So let's move on from this. Okay, let me do that. I just spent 5 minutes explaining things. Okay, didn't realize that. So since I said the first 4 bits are what? Are your operation code. Now our first operation is to move, which is to load what's in location 4, what's in location 6 to the accumulate. Now what is the code for loading? The code for loading is 1 basically. Now since it's 1, it is represented as 0 0. That is our 1. Then the next 3 times 4 bits, it represent the instruction, right? The instruction memory. Now the instruction memory is from 6. Therefore, let's start here. Our 6, it is represented in terms of a 4 and a 2. Now we have our rest other bits. Now let's move. Now since whatever is in location 6, it is moved to the accumulator. It is for us to move whatever is in the accumulator to what? To the memory location 8. Now our second iteration here. Now since this is a 16 bits memory, it means that our iteration it iterates in 2 times, meaning 2 4 6 8 10. Now you all already know that program counter always start at 0, right? Unless you whatever you did it, you did to it for it to start wherever it is starting other than 0. So basically we are looking for an operation code which says move from accumulator to your memory. Therefore let's check this one out. Accumulator to a memory. Now store accumulator in memory, it is represented in 2 binary. So let me just put that back. It is represented in 2 binary, meaning that we have 0 0 1 0. Now this instruction, it is happening where? It is happening in number 6 in the memory, meaning that no in number 8, I'm sorry, in number 8, meaning that we have 4, we have what? We have 0 0 0 0. Now it is represented in this way. Now you must understand that when you are done with your instruction, you must stop and then proceed with what? With your data values. Then it means that this next step, it is for us to stop. The iteration, it will be, since it's 0 2, it will be 4 0 0 0. Now this rest will be just zeros and then 0. Then our stop operation code, it is 0, meaning that it is here. Now as I said before on the previous video, if you watched, the operand, if the instruction of which is being executed, it is not given. If the instruction it is not given, it means that it is not there on the memory. Then if it's not there on the memory, its value is 0, meaning that we are proceeding to write 0 here, 0 here, because it is not there on the memory. Now after stopping, you now proceed with the initialization of what? Of your data. Now our first data, it is 255. Now let's represent that in a binary code. Let me just move that down there. Then our following iteration, it will be what? It will be 6, which is 0 1 1 0, then 0 0 0 0, then we are having other 0 0 0. Now our operation code for initialization, it is not there, meaning that it is 0. When the operation code is not there, it is 0. Therefore, what is the value that it is being initialized? It is 255. Now, 255 can be represented in every other data. Okay, let me just do this. You will add your 8, your 4, your 2, your 1, your 32, your 16, your 32, your 64, your what? Your 128. And then here we have 256 actually. Therefore, this is the representation of what? Of your 255, right? Now, let's represent 0 on the next iteration. Now, the next iteration, which will be 8, will be represented in this manner: 0, 0, 0, 0. Now 0, 0, 0, 0. Then, since I said the operation code for initialization, it is not provided, therefore it is 0. Now we want to initialize a data value 0, meaning that it is 0. There's nothing here, just like the rest. Now you stop your what? Your what's this? You stop your conversions from natural language to binary, meaning that we are having the following. Since it's 8 here, it means that now we are having 10. But then this last step of stopping, it's not that really necessary, but you can just include it just in case, right? Now our stopping, it is 0, 0, 0. What are we stopping? What's this? An instruction which is not provided, 0, 0, 0. So most of the time you don't need to write it because it's already provided above actually. But then, you know, this is it. Now let me just touch a little bit of this part. I want to touch everything at once actually, just to explain, right? Let me just remove this, and then so let's explain this again, right? This here is your OP code, operation code. This here is your operand. This is your operand. Now your operation code is always provided. Basically, it just represent the instruction. Now your operand, it represent what? It represents the memory of instruction or the value which is being executed or being moved, right? Therefore, we are done with that part. Now let's move to the other part. Now this part is just represent the iteration, which is the location inside the memory where the address is or where the value is, right? I think you understood in that one. I think we are done actually. So yeah, if you have a problem, question, drop there in the comments.